So today we're going to look at our quadratic formula, but actually just focus on the discriminant, and that's the part underneath the square root. That's the b squared minus 4 times a times c. So the discriminant is the value underneath the square root, and that helps us determine how many solutions we're going to have. Remember, solutions, if we were to graph a quadratic equation, are where the x-intercepts are. If, when we calculate b squared minus 4ac, if what's underneath the square root is positive, we're going to have two real solutions. And a graph for that would look something like this. So there's my x and y axis. We get two x-intercepts, two solutions to that equation. If, when you solve this, you get 0, when the discriminant is 0, that means you'll have one solution. That means the vertex, or the bottom of an upward facing parabola, the vertex is the only one point that actually hits the x-axis. You only have one solution. Or if it's a downward facing, the top of the parabola, or the vertex there, is the only value that hits it. And then if you get a negative number, we can't square root a negative number, so we can't actually continue on with the quadratic formula. We can't continue on getting solutions. That means that our smiley face parabola is actually above the x-axis, or our frowny face parabola is below the x-axis, like that. So let's take a look at an example. So here, our discriminant, when we calculate it, remember it's b squared minus 4 times ac, is going to be, so our b value here is negative 10. I think that's a minus sign. Oh, it's a plus sign if you look closely. So we have 10 squared. Although actually when you square it, it doesn't matter. Negative 10 squared and positive 10 squared are both 100. Minus 4 times 1 times 25. So here we get, if I simplify this and show some work, although you can just punch this in all at once, we get 100 minus 100 minus 100, which is 0. So that means that we have one solution. And if we were to continue on with our quadratic equation, we have the opposite of b, which is negative 10, plus or minus the square root of 0. Well, the square root of 0 is just 0, all over 2 times a, which is 2 times 1. So we have negative 10 plus or minus 0 divided by 2. And yeah, we don't really need to split here, folks, right? The split gives us two solutions. Well, adding 0 or subtracting 0 from negative 10 doesn't matter. It's still going to equal, in either case, it would be negative 10 divided by 2. So I'm going to actually show the split, but you don't need to do this. So it's negative 5, or this would also be negative 10 divided by 2. So there is our one solution. In our fancy pants bracket, we've got negative 5, and that's it. The graph of this is going to look like this. Our x-intercept is at negative 5. The parabola just touches, whoa, the x-axis at negative 5. I put a big dot there to just kind of cover up my unfortunate picture, but that's roughly what it would look like. You get the idea. So here we go. Now calculating the bottom left corner one, our discriminant is going to be b squared. So 1 squared minus 4 times a times c, which is negative 15. Here I like to, if we're going to kind of do this manually, you could punch this all into your calculator. If we change that subtraction to adding the opposite, we're going to have 1 plus a negative times a negative is a positive. So this product of the three numbers is actually going to be a positive number. So you get 361. That means it's positive, so we're going to have two solutions. So I can plug that back into the quadratic formula. The opposite of b plus or minus the square root of, I already did the b squared minus 4ac and got 361, all over 2 times a, which is 6. The square root of 361 is 19. So we have negative 1 plus or minus 19 divided by 12. So now we do have to split. This is how we get our two solutions. Adding 19 and subtracting 19 are two different operations. So negative 1 plus 19 divided by 12 and negative 1 minus 19 divided by 12. So we get 18 twelfths, which is the same as 3 halves. And we get negative 20 over 12, which is negative 10/6, negative 5/3. Boom. So your graph is going to look about like this. The parabola, which is a smiley face parabola, is going to go right between 1 and 2, and then a little bit more to the left of negative 1/2 right there. Whoa! So there we are. By the way, your y-intercept is that value is the constant, so that'd be at negative 15, but we really haven't talked about that a whole lot. Last idea, folks. Let's do the discriminant. So we got b squared, so 2 squared minus 4 times 1 times 5. Oh boy, we get 4 minus 20, which is negative 16. So that means there are no solutions. And we can't calculate them. And the graph of this would look like something like this. Shoop! With a y-intercept of 5. And a vertex somewhere down there. Refer back to these notes as you calculate the discriminant to determine whether or not they have 2 solutions, 1 solutions, or 0 solutions. The answer key might call those 2 imaginary solutions, but we're just going to call those no solutions right now in Algebra 1. You'll learn about imaginaries in Algebra 2. Yeehaw!